University of Malaysia, Pahang, Faculty of Computing. My research topic is comparative study of job scheduling using priority rule and machine learning. This is the overview. In here, we'll describe about introduction, our research and procedural applied algorithm, workflow in machine learning, performance evaluation, result and discussion. And finally, we'll conclude describing about conclusion and our future work. Now, we'll describe about introduction. In here, first we have to know what's cloud computing. Cloud computing is the provided service to the internet. It may be an application or any tool such as database, network, server. In cloud computing is being more popular in this era because all kinds of information, what is storage in cloud, can be accessed remotely or virtually. And there are many types of cloud service provider. The user sends request to the service provider. Based on the request, the service provider provides the service to the user. Then we have to move what is the job and what is job scheduling. When the user sends request to the service provider, at a time many user can request to service provider to take a location. At that time, all service provider made a queue based on the request. The request is called job, and the queue where all job are stored is called job scheduling. Based on the request, using some algorithm, a new scheduler is created by the service provider. In here, what is our contribution? For job scheduling, the more popular is the heuristic and meta-heuristic. But in here we use one machine learning algorithm, not one. We just show one machine learning algorithm, but we use several machine learning algorithm and made a comparison between the priority rule and machine learning algorithm. Research design and procedure. In research design and procedure, first we have to know job. What is job? Job I already described. That is what is user sends request to the service provider. The request is called a job. Then all job are stuck in a queue. That is called waiting queue. Then waiting queue. From this waiting queue, some algorithms such as priority rule or machine learning algorithm are used to make another queue, what is called main queue. Main queue in here, based on priority, they made another queue, what is the main queue. Finally, resource are allocated. Resource means any kinds of memory or virtual machine, data center. These are allocated after the main queue. Finally, it's executed one job taking from the main queue. What is the procedure of applied algorithm? The procedure of applied algorithm in our case, we divided two parts. One is priority algorithm and another is the machine learning algorithm. In priority algorithm, we use two most popular algorithm. One is shortest job first and is longest job first. We did all work or shortest job first and longest job first for both timeshare and timeshare and space share. Mainly, the share allocation is only for the virtual machine. But sometimes in some case we use the virtual machine in timeshare mode. Some case we use the virtual machine in space share mode. In the machine learning case, we use different types of algorithms such as linear regression, Adams classifier. But we describe in here Adams classifier. Why we describe Adams classifier in here, we'll describe it later. Workflow and machine learning. Actually, in machine learning data set, how we complete it. First, we have taken data set. What is actually data set? Data set means the number of processing elements and the clouded LAN, number of virtual machine, number of data center. It's actually data set. After getting the data set, we pre-process the data set. Then finally, model building. Model building means that we implemented some robust machine learning algorithms such as Adams linear regression, impact learning. Then among all of these implemented algorithms, we made a comparison among all of the implemented algorithms to take the performance. We found that Adams classifier is the best performance for this data set. Then we show our result. What is the output of this data set? Here we count the 5 performance evaluation. First one is CPU time. CPU time means that take to complete one task. It is the CPU time. Execution start time means when actually one job may come in start maybe 5 seconds ago, but it starts after 8 seconds. The 8 seconds is the execution start time. Means when he gets the CPU is the time is the execution start time. Turnaround time. Turnaround time means arrival time and the end time after completing the time of the job is the total time, means the turnaround time. Waiting time, before getting the CPU, some job have to wait in a queue. That is the time, how many times they wait in queue, that is called waiting time. Walk of time. Walk of time is one kind of CPU time, but it is used for multitasking performance. In here, for each job, for each program, walk of time is fixed. Finally, in our resultant discussion, we try to show the comparison between shortest job first, longest job first, and Arabus classifier for both timeshare and spatial mode. If I consider CPU for timeshare mode, we found that shortest job first output is very good, and the longest job first output is compared to the bad to other existence or implemented algorithm. But for spatial mode, we found that longest job first is better. In execution start time, we found that shortest job first and longest are both do well, better performance. But in spatial mode, shortest job first do better. In one case, we found that waiting time, we found that in spatial mode, Arabus classifier did very better work compared to other two algorithms. Conclusion and future. Actually, we have a plan to implement some heuristic algorithm to make the comparison with the heuristic algorithm and the machine learning algorithm. Besides this, we'll establish a hybrid algorithm using the priority rule. Then we'll make a comparison with the existence algorithm. And we have another plan also that we're using a backfiling technique. Using backfiling technique, we will make another job scheduling. That will be done in our future work. And thank you. This is the end of our presentation. Thank you everyone for watching, for enjoying the presentation.
Okay, thank you, authors. Solid, can I ask the questions now?
Yes, sir.
Okay, so the first one, Murad, are you with us?
Yeah, I'm in touch with you.
Okay, okay. So I'm loud and clear. You're hearing me properly?
Yeah, I'm hearing you.
Okay, great. So Murad, the first question that came into my mind, you say, okay, using priority rule, right?
Yeah.
So you specifically mentioned in your title that you actually comparative study on job scheduling using priority rule and machine learning. So my first question, machine learning is a broad area, right? So in machine learning, we have supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, active learning, not other learnings. Why not you specifically mention the particular algorithm, say for example, adaptive boosting or AdaBoost that you use, right? As you mentioned the priority rule, you may mention adaptive boosting, right? That will be more focused. Is it clear?
Yeah, so, I'm clear.
Right, right. So my question now, so why AdaBoost? So there are other ensemble techniques. So AdaBoost is an ensemble technique, right?
Yeah.
So first question, why AdaBoost? So did you compare your approach with other technique like random forest or any other baking method? This is the first question.
Yeah.
Right.
Now I answer.
Right, you may answer now. Right.
Okay, thank you for your question. Actually, I do not use only for Arabus classifier. Besides this, I use linear regression. I already mentioned in my slide.
Okay,
but
then my question is, so linear regression is not an ensemble classifier. Linear regression is a single model classifier. And linear regression used for regression problem, right?
Yeah, right.
And AdaBoost is basically well known for classification problem, right?
Yeah.
So the first question, the problem type is different. Linear regression is good for regression, Adabust is good for classification, even linear regression is single model classifier, and Adabust is ensemble model classifier. So what is your justification to compare the performance of these two algorithms?
I used another algorithm, impact learning. Actually, impact learning is not popular. Actually, we developed this algorithm
previously. So answer the first question, like why actually you did compare between linear regression and Adabust? Because you know their nature of task and the learning process is different. So is there any meaning to compare these two algorithms?
Actually, after implementing all data sets, when I put my data, at that time I found that linear regression also giving me a output, and besides this, I also getting another output for Adabust classifier. From among all of these results, I found that better.
Right, but there should be some justification. So, what was the baseline classifier for Adabust algorithm?
Actually, I did not got it.
What is the baseline classifier? So, for adaptive boosting algorithm, you need to decide a learning method, right? Learning algorithm. What was that one?
Yeah. Actually, I did not measure this issue. I just implemented.
So, no, you implemented fine, but when actually implement the Adabust algorithm, there should be some base classifier, right? That basic model. What was that model? Or basic algorithm? What algorithm actually you used for Adabust algorithm?
I have to check it. Actually, I forgot it because I did it previously.
So, right. So, Mura, thank you for your presentation. These things should be more, you know, now using machine learning become very common. So, we try to use everywhere. The machine learning is everywhere. But we really need to understand why actually we are doing this and what is the reason, what is the effect of applying these kind of tools or algorithms, right?
Okay.
It's clear to you, okay.
Yeah,
I wish all the best to you. Thank you very much. Okay. Thank you. So, Sonnet, can we move to the next paper?
Yes, sir.
Okay, the next paper ID is, right, Alaikum Islam. Next paper ID is 23, Transfer Learning on VCC 16 for classification of potato leaves infected by bright light diseases, right?
Yes, sir. Paper number 23, sorry.
Okay.
Assalamualaikum. Welcome to research presentation. The research title is Transfer Learning on VCC for the classification of potato leaves infected by light diseases. Myself, Jason Akhtar. Co-authors are Mohammad Harunul Rashid, Alahid Noyon, Professor Muhammad Ghulam Jibril sir. The outline of the research, aim and objectives. Plant diseases are one of the most important events affecting food supply and domestic production losses. That's why creating food insecurity and crop disease reduction huge losses around the world. As computer vision empowered with the artificial intelligence has tremendous promise for improving agriculture, namely agricultural intelligence as a part of the industrial technological revolution. As deep learning approaches have recently expanded their applicability in land-based identification, providing a comprehensive tool with extremely accurate results. The next outline is motivation why for this research need to do. Plant diseases are one of the great challenges that face the agriculture sector worldwide, where agriculture contributes to 6.4% of the entire world economic production. Blight is still a global danger to potato crops and so many more crops, costing an estimated $6.7 billion in output losses and management expenses each year. The fungus like Thesis causes black lesions and other diseases symptoms in vulnerable cultivars, quickly destroying the plant's leaves, its fruits or tubers. Our next outline is about related work. In 2018, Barbados suggested an automatic plan disease system where they proposed the most popular classifier deep learning convolution neural network method, which overcome some of the critical challenges. Then it all laid out the criteria for choosing a convolution neural network method and finding a prepared deep learning approach for the method-based application due to obtain robustness and performance intelligence. This is a project based on survey of artificial intelligence and deep learning application in robotic harvesters, where robotic approaches can be minimize the disease detection to detect disease efficiently and earlier. Darwin is all focused on using two frequent convolution neural networks to create an automatic classification model that distinguishes between infected and healthy male beings. Their models are all trained with an asymmetrical rate schema, which affirms alternative approaches. Their experimental results are compared with the performance of other CNN models, namely infection duty and exception, whose hyperparameters are selected using a non-evolutionary method. The next outline is about the dataset used in this research. Potato blight leads criteria of digital images. Two containing datasets with early blight and the late blight of potato crop. Early blight symptoms are irregular black spots on the leaves of potato. On the other hand, late blight symptoms is the leaves appear on large black spots, sometimes yellowing around the circle, black spotted, and seems damaged, and even if the whole crops of potato got rotten or damaged. Proposed task detection. To do the research, first of all, need to survey these images both early blight and late blight. Around 10,000 images are selected during the localized area field, and there in all the images are digital images and various hardware devices like Android phone, iPhone, and digital camera smart devices. All the images are digitally categorized, so need to be processed, and as various hardware devices are used for the images, their resolutions and dimension or filtering are not exactly same. So, various online photo editor and filtering are effect on the database. And PC default editor also used, sensor also used to ensure the datasets, all the dataset images are in same size, resolution, and color. Label sample for the next step, as it is need to classify the two datasets as early blight classes and the other dataset is late blight classes. Then the BBB system model, customized models are used for model training, model testing, and validation. These models customized BBB system model to classify detected disease categories as it is early blight or late blight. Here is the two figures. Figure 1 mentioned the customized disease system, and figure 2 how to disease system can be customized for the research lab. Here from figure 1, see that a late blight image is inputted and two convolution layer followed by a pooling layer, and this criteria followed by 2 times. And next three convolution layer followed by a pooling layer. This criteria of layers followed 3 times. And the outputted layer times layer is added before that pattern layer added for 1 dimensional, as the inputted image has digital image are daily, that is 3 channel. So pattern is for 1 dimension. So 3 channel image are 1 dimension can be processed for this disease. And as this is the two category of classification, so need to outputted image transfer into. In figure to clear this last layer, that disease system is source image dataset and the disease system layer of model, then outputted as large dataset, that is 1000 classes of infinite database, where customized PDB system. Here, three image datasets are deployed into PDB system model, where the last layer of the PDB system model customized into two unit software tenants layer instead of second last tenant layer. So the output as two classes of PDB. List of component use. Hardware for capture images uses digital camera, Android phone camera, Android output, and preprocess implementation, Dell installation, Thesis 674i7 laptop. Software used here Google Collaborative for implementation and video provided by Google Collaborative and also Virtual and Google Drive for storing the datasets. Language used here Python 3.90 version and the library used Keras. The research text output. Here the line of green shows the epoch loss and red shows the validation loss, orange shows the validation accuracy, and green is for blue is for accuracy. Validation accuracy is the most important topic part in the graph. Here after 17 epochs shows that the validation accuracy is approximately equal to accuracy. That means it is clear after 17 epochs the validation accuracy is high to 96.33% for this research. Specialty of the research. The built model of the customer system can be deployed the model into Android devices or to apply real capture disease detection or answer disease detection. Firstly, the model deployed into Android Studio and designed and implemented part with Java operating can be develop a device-based detection of disease. Business system model is user-friendly to implement this kind of work. That is why when there is small set of data, as this system has learned more lots of OS and features, so can be do another task of dataset would from present the green feature. Users process and guidelines are easy to implement as the users feature and process are available in the internet or website. Conclusion: data learning is the potential to help overcome digital image detection problem and adapt the model to the new task as it is adapted for their present feature into a small dataset. Built model has been tested that performs well for both web and mobile approaches. This approach can be used similar for modern computer vision, deep learning, and artificial intelligence tools. So here is the research presentation. Thank you, everyone.
Thank you, Jasmine Akhtar. Thank you very much for your presentation. Sonat, may I ask the question now?
Yes, sir.
Yes.
Okay.
Yes, sir.
So, right, thank you. So, Jasmine, are you hearing me properly?
Yes, sir.
Okay, great. So, first thing, you work on transform learning. That's really interesting. On VCC 16 for the classifications. So, is it multi-class classification or binary class classification?
Sir, this is for binary classification. As the dataset is into two sets, two kinds.
Okay, fine. And so VG16 is basically the CNN model, right?
Okay, sir. Yes, sir.
Convolutional neural network model.
Yes, sir.
So my first question: what is the filter size that you set?
Sir, the filter size polling size is 2x2, and input image size.
I'm talking about filter size. The first thing, the filter. So is it 2x2?
Yes, sir. Sir, when convolution layer used, then I used then I also used 2x2 ReLU and convol.
So what is the normal range that the filter size should be?
Sir, I actually used.
It should be 3x3 to 7x7, right?
3x3, yes, sir.
Right. So why actually you use 2x2? Is there any reason?
Sir,
but the standard approach is to 3x3 or 5x5 or 7x7. Instead of that, you used 2x2. Why?
Sir, firstly I have to use it in normal convolution layer. Then I got the accuracy not satisfied. Then
My question is, like you said that you use 2 by 2 for filter size. My question is, why you choose 2 by 2? Why not 3 by 3?
Sir,
Is there any reason behind that?
Not very specific, but
Okay. Okay. So, what about pooling layer? So, why pooling layer? We use actually what's the advantage of using pooling layer?
Sir, after convolution layer, we got the features, and then after that we pooling layers to minimize the features and extract the most of the features that layer. Previous
Okay.
layer.
So, what is the activation function in your model?
ReLU.
Okay. So, can you explain how it works?
Sir,
how ReLU works?
Sir, ReLU appropriately identified the value as a integer value like 0 or 1, not a
Is it
fractional.
0 or 1? Say, for example, if say for the total sum of the input is say for 10, then what will be the output? Is it 1 or 10?
Sir, 1.
No, that will not be. That will be 10, right? So, right. So, when you say okay, you know they're applying these kind of algorithm models like DC16 or EOLIS really easy nowadays, right? Even
Yes, sir.
so collect data is also very easy because there are a good number of data repositories. But the basic things, when actually you are applying the algorithms, do you really understand how it actually working? The internal process, how actually, why ReLU, why not the other activation function, why filter size is set 2 by 2, why not 3 by 3? So these are the really important things, right?
Yes, sir.
Okay. Okay, thank you very much, Jasmine. I wish all the best to you. Thank you very much for your presentation. Okay.
Thank
so
you.
Sonnet, can you go to the next paper? Sonnet, are you listening? Can you go to the next paper?
Yes, sir. Next paper is paper number 77.
77. A machine learning approach to predict renal diseases with SARS.CoV.2. Right.
Hello, my paper ID is 77 and my research topic is a machine learning approach to predict renal disease in SARS-CoV-2. And I'm the presenting author. My name is Pritilota. I'm from Institute of Information and Communication Technology, Pune University of Engineering and Technology. Here is my paper outline: abstract, introduction, related words, proposed methodology, experimental results, conclusion, references. Abstract. The fundamental motivation behind the research is to foster a system that will help people in predicting the risk of consistent renal disorder developing that subsequently being contaminated with COVID-19. We have utilized 773 raw data and trained them, and we have also used our data. We have used KMM mean bias in a model and colony optimization, which is known as SEO, are used here for making the system ready for assumption. The accuracy that we acquire by utilizing KMM is 95%. Mean bias is 98.30%, KMM is 97.5%. And colony optimization. There are multiple varieties of COVID-19, which are delta, alpha, beta. The assessment found patients with COVID-19 who were hospitalized between March 11 and April 26 were twice as inclined to encourage AKI, which is known as acute kidney illness, which appears differently in relation to non-COVID-19 patients who made AKI during a comparable period of time in 2009. 6.9% versus 25.1% separate. The motive of our research is to analyze renal diseases with Delta variants, and we try to figure out the correlation between COVID-19 with the Delta variants. related work. My first paper was discussed about recognizing the seriousness of COVID-19. Here, the author's motivation was HHO to improve FCLNS skills, boundaries, and component subjects at the same time. In this paper, they applied diverse machine learning arrangement strategies, which involved 400 examples to inform components and two for characterization them. Every one of the trials were actively mapped out, and the performance was better. In this paper, authors proposed a framework from which it would recognize the danger of CKD, which is chronic kidney disease. They utilized 455 patients' information, and the decision took place by random forest calculation and in. Here is our workflow chart. First of all, we collect raw data from online as well as offline and assemble the data properly. Data pre-processing was handled. Most significant features were extracted and we changed the data set properly, and after that we use here and SEO and mobile on it. Finally, we got the expected results. Proposed methodology: raw data assembly, data pre-processing, machine data handling, most features extraction, cross validation, tenfold result. Data set. Here were not many elements in the data set which was not applicable to the code. So missing data handling not able to pick the good result. Here the number of instances were 773. Number of features was 24, and number of class 2 positive samples were 79% and negative samples 6%. Here is the experiment results where we can see that from 10 years neighbors algorithm, we get the accuracy from here 95%, error 5%, precision, recall, and integer are 0.95. From neighbors, we got the accuracy 19.30, error 1.70%, precision, recall, and integer are 0.98. And from ANN, which is known as artificial neural network, accuracy 97.5%, error 2.5%, precision and recall 0.97, if measure are 0.9. And cornea optimization, accuracy 95.5%, error 4.5%, precision, recall, and if measure are 0.95. Here is the experimental results. We will have to take steps if we know about the seriousness of our disease. That is why prediction is important, especially for those who are already infected with COVID-19. Our research showed that how much risk we are in this pandemic. It's just a survey which can help us with the prediction ratio and discuss our so that we can take necessary steps in time. Here is the experimental results where you can see that before COVID kidney disease and after COVID kidney disease ratio.
হ্যালো, তুমি জয়েন অনেকেই
Devastating
দিচ্ছে
spread of
এখনো।
COVID-19 throughout the
আমি
world
সবাই আছি।
has caused global lockdowns as well as a huge impact for medical crisis. Who are already suffering from acute kidney disease are
আমারটা
in
তো
the
শেষ।
higher risk
আমারটা তো
stage
শেষ।
pandemic.
স্যাররা বলতেছে ভালো
Researchers
হয়েছে
think
ব্যাপারটা,
that
মানে
after
কোশ্চেন
COVID-19
হ্যান্ডেল করতে পারছি এটা
failure,
বলছে।
yes, is a chip fear.
আর
But COVID-19 can lead
okay.
people to the acute kidney disease, especially for themselves who were already suffering from hypertension and diabetes. We use machine learning algorithms so that the results will be more accurate and smarter because as models are exposed to new data, they are capable enough to adapt. But the major limitation was all the samples were not tested because Delta variant that time we collected data were Delta variant was so much popular and we were not 100% assured about whether the bias is delta or not, but some values or some test results are actually delta variable. So this is the major implications of our paper. Here is the references we have included in our presentation.
Thank you. Thank you very much, Preeti Dutta. Thank you for your presentation. So may I ask you the questions?
Yeah, sure. But I'm kind outside of my home and in the hospital for some medical emergency. So please pardon me for my network issue.
So there is another author. May we ask some questions? Because some of the audience or
I'm here to talking about that.
Okay, just very basic questions like say you use KNN, net-based classifier, artificial neural network, and colony, but there are several other machine learning algorithms. Why you specifically or choose these four of them? Like say, why not others like subordinate to machines, decision trees? Why you actually choose these four algorithms?
Thanks for your question. I chose KNN because supervised learning, because it is supervised, and net-based because it is easy and fast, and ANN for because it is able to learn and non-linear and complex and try. It is better to better for solving non-linear and complex
issues. So your problem is a binary class classification problem, right? As you say, the class values too. So you know the KNN is a lazy learner. KNN doesn't build any model from the data. So what is the meaning of using KNN then? So it actually doesn't build anything, right?
Yeah, but I used other three of our algorithms here also.
But what is my first question is, you know, the KNN is not is a lazy learner, so it doesn't provide you any decision line or something. So why actually use KNN? Even you know you use net-based and classifier or ANN, artificial neural network. So these are very strong algorithms. So what is the reason that you actually compare or try to compare KNN with net-based classifier or artificial neural network?
Okay, because it makes highly accurate prediction and it gives.
Okay, what was the value of K? So, what was the value selected for K?
to join second
sorry, I didn't get it.
You use KNN, right? So the value, what is the value of K?
click করলে zoom on হয়ে যাবে
K was 1, K was 5, K was 10, or K was 100.
just তোমার ছবিটা দেখার জন্য
Okay, how did you decide K is 10?
I'm extremely sorry.
Okay, so another thing I found that your data was quite imbalanced, right? The positive samples and negative samples. Right. So, so how did you handle this situation? Like, okay, so if you build a model on imbalanced data, then model is biased to the positive samples, right? Okay, how did you deal with this situation? Like, how did you balance the data?
In my paper, I included it median strategy I use here. Actually,
I'm not getting your answer. So, in the paper you mentioned what is the methods actually used for balancing data?
Sorry, median strategy I use here. Actually.
Can you just briefly explain the method?
Yeah, I'll try.
I have a few questions also. Right. Saddam, I'm giving flow to you, right? Okay. So, right.
So,
okay, Saddam, right.
Can you explain about your data set? How did you told that you have 24 features. So you did not show what are those features.
Right.
Because sure.
Yeah, please tell.
Okay, I collected data from nearby hospitals, Pune Medical College and Pune City Medical, and some are online also. And I used 25 features there. The attributes are blood pressure, urea, serum creatinine, sodium, potassium. Related to our CKD, hemoglobin, fat cell volume, WBC count, RBC count, attention.
Okay, so a total of 24 features you have collected, right?
25 features actually.
Okay,
but,
so how did you find the significant features? You did not mention that as well.
Okay, significant features are found chi-square testing.
Why chi-square? Because your features are continuous in the independent side, and dependent side is categorical. If all those features are categorical, in those cases you should use chi-square. Your independent feature is continuous, I believe. It's continuous?
Sorry, I'm sorry. I can get it. Could you
what is the type of your independent features? Is it continuous or is it categorical?
Both.
Both. So in continuous cases you cannot use the chi-square test. You should use other feature.
I tried to convert those data, and then
how did you convert? You discretize it?
I used cross validation here.
Cross validation. Okay, actually I did not get. Okay, it's just for get it over. So I have another question. So why your ANN is performing weak in the naive bias? Actually, so which ANN you use feed-forward or any other maybe deep learning based network? What ANN model you have used? Feed-forward. Oh, okay, and that's why. Okay, I'm done with the question. Thank you.
Thank you, Dr. Sattam. Thank you for asking the question. So, Pritiroda, thank you for attending this session. You are in a hospital. Sorry for that. Okay, we wish all the best to you. Thank you very much.
Yeah, thank you so much.
Sonet, can we move to the next paper?
The next paper number is 78.
Right, towards efficient segmentation and classification of white blood cell cancer with symmetric segmentation and transfer learning.
Hello everyone, thanks for giving me the opportunity to present our paper in 2021 Emerging Technology in Computing, Communication and Electronics. Today I am going to present my paper which is towards efficient segmentation and classification of white blood cell cancer using deep learning. So the authors of this paper are Ashik Iqbal, Muhammad Faisal Ahmed and myself, Muhammad Naim Shubhan, and Shourab Das Shubha and our supervisor Ahmed Fahmi. So cancer is a disease that occurs when a cell growth is uncontrollable, and multiple myeloma is a cancer that forms in a type of white blood cell. So that's why it's also called white blood cell cancer. So in multiple myeloma, cancerous plasma cells accumulate in bone marrow and crowded out healthy blood cells. We affected our healthy blood cells. And there are a variety of foreign technology to detect this multiple myeloma or white blood cell cancer, which is yet not available in our Bangladesh. So we thought about making a like technology which can help our country. It's still in the research process. So in this research we have tried to recognize myeloma cell, which is the reason for white blood cell cancer from microscopic bone marrow images. So we have taken the dataset from MIM, the SBU lab dataset, and the images were taken from bone marrow express slice of patient diagnosed with white blood cell cancer, and it was taken with Nikon 2000 with 1000x microscopic features. And the images, the format of the images was the BMP, and the shape of it to 2560 into 1920 pixels. So the images were single images were quite big in size, one image was 100 MB or something like that. So in this whole data, we have only 85 images with a purpose line where the myeloma cells are annotated, shown only that these are the myeloma cells, so that we can annotate the myeloma cells in our work. So the most important thing as our work is divided into two parts. One is myeloma cell recognition, which we will do by this segmentation, and another one is detect the myeloma cells. For segmentation, one thing is very important, which is data annotation. So here you can see, from the PowerPoint slides, there are they mark the myeloma cells. So by seeing this mark, we have annotate level myeloma cells by pixel wise, by creating a mask and then given a class of it, like myeloma class. So for our segmentation project methodology, we have used mask RCNN, which is a hybrid RCNN model. Mask RCNN is a combination of first RCNN and FCN, fully convolutional neural network. So what is the benefit of mask RCNN? The benefit of mask RCNN is that it doesn't give only one output or something like that. It gives three outputs. So the first RCNN, which is this one, like this plus, so this gives outputs of class prediction, like is myeloma, non-myeloma, something like that, and it also gives the bounding box of the detected area. So that is for first RCNN. Then the FCN, fully convolutional network, gives the pixel-wise mask area. Like it gives the exact level, the annotation we have done. It tries to give the same annotation or area, the exact area of the myeloma cell. So there is a backbone of these two other networks, and the backbone is using CNN, and the CNN is on default is ResNet 101, and also you can use ResNet 50 for the backbone CNN, which actually extract features from the images, then give this to the other two networks. So evaluating the model, so first of all we have trained our model with 30 epoch, and as we have three output. For three output we have three loss function. Like for bounding box loss we have 0.29 loss. Then for class we obviously class 0.09, which is much lower. That means it's much accurate, and for the mask it gives 0.3, so which is not also that much bad. So as an object detection and segmentation, the finding accuracy is quite tough, but for object detection and segmentation we can calculate the MAP, which is mean average precision. So we have ability with our validation data set, which have only 20 images. So as we have split it in 65 images for training and 20 images of validation and testing. So our validation and testing data set is same. So we have write a function where every time we run the detection, it will select random images from the 20 images as and give your desired output. So after evaluating, we got an MAP of 93% for our segmentation model. So here you can see the detection. This was the actual leveling of the image, and you can see this is myeloma cell, this is myeloma cell. But after running this, input this in our model, it gives the exact mask of this. The mask is not that quite good all the time, but it's able to detect it with one error only, because this was not marked as a myeloma cell, but it is showing here, but the classes are detecting, as there is only one class myeloma, and so it's quite easy to get the class detected. So, and also with how much accurate. So you get three output here. This is the class, this is the bounding box, and this is the visualized mask value. So for getting a better like visualization of the output, we have done a color splashing. This is called color splashing, where the detected area of the myeloma cells remains RGB in RGB format, color format, and the rest of the images become grayscale, like black and white. So by doing so, we can visualize our output or myeloma cells quite good. So after that, as we have done already, how to detect, how to recognize the myeloma cells. So now for our extended work, So we have what we have done. We have cropped the myeloma and non-myeloma cells, and the images look like this. It's a little bit small after cropping. Then what we have done after cropping all the data, we have got 1,452 myeloma cells and 1,116 non-myeloma cells, and we have split it as we're going to make classification model right now, and the classes are myeloma cells, non-myeloma cells. So we have split it into 18 to 20% ratio. So our training has 2,105 samples, and testing has 500 to 524 samples. So for classification, we have used transfer learning. So as a pretend model, we have used efficient B3. We have used efficient B3 knowledge. So efficient B3 is a pretend model. So first of all, we have removed the efficient B3 fully connected layers and added our own fully connected layers, and that is the number of classes of our dataset, which is only 2. Then randomize the weights of newly fully connected layer and fill all the weights from the pre-training network. So there are some common parameters of our efficient net model was like for loss function we have used categorical concentrity. For optimizer we have used ADAM. We also tried other optimizer like SGD, statistic gradient descent and all, but we found ADAM is the most suitable. Then for initial learning rate we have used 0.001. So for the reason for there are many predictive models like DC16 and ResMP2 which are also good, but the reason for choosing efficient B3 is that efficient net is 8.4 times smaller than all the other pretend model exists, and it's also higher in accuracy. So there are other version of efficient net like efficient net B4, B5, but which are much complex than this, and that's why we only use efficient net B3. So you can see the after training in 30 above, we have got an accuracy of around 95%, and you can see that our training and validation accuracy is quite around 95. So it's quite a good sign. So for loss function, it's also decreasing way. So this is our accuracy and loss in epoch. So in every after 5 epoch it's increasing. So it was in increasing mode. Sometimes it's dropped, but it was in increased way. So we could have take more epoch, but it would overfit our model. That's why we didn't. So for evaluating our model, that it is not biased, the accuracy is not biased. So we have construct a computation matrix where you can see for myeloma cells we have 291 samples for testing, and from 291 it detected 286 myeloma as myeloma and 5 was wrong. So our true positive was 286, and there is a non-myeloma was around 240 or something like that, and 212 is right, corrected right, and the 23 was 0. So in total, the errors are 28 errors only. So you can see that our model is not biased towards one class. So for evaluating one model, for non-myeloma there are also some white cells also like this kind of cells because there are non-myeloma there are many cells this. So we have tried to detect now single images, like after training the model, as we have used PyTorch. So we are like showing some small like code here, and our detection, like this one they predict myeloma, which is actually myeloma, and this one PyTorch class is non-myeloma, so it's detected one like non-myeloma. So that's it for our paper. If you have any question, you can ask me. Thank you so much.
Thank you also for presenting the paper. So thank you very much. So are you hearing us?
Yes, hello.
Okay.
Thank you so much.
Right. Okay. So my first question, so you talk about the overfitting, right?
Yes, yes.
So you got 95% accuracy using NetB3, and
Yeah.
so how actually you handle this, so like the scenario, like the overfitting problem? So how can you make sure that your model is not overfitted?
Actually, by like finding the precision, we did like we did show it in our paper, the precision and recall and all. But actually, by finding the coefficient matrix, so we have like seen that there is not that much like the equal.
Is it possible? Is it possible to say by seeing the confusion matrix of precision or recall value that the model is not overfitted?
Yeah, because like our like tested and validation set was same here. So yeah, overfitting can say.
Okay, so dealing with overfitting problem, what are the things or what are the steps actually you have done in the experiment? Actually, what actually we do for
Yeah,
addressing
normally we can
overfitting
do
problem?
cross validation, of course.
Cross validation.
Yeah, cross validation. We can use care for it or cross validation. We can define our validation.
Okay, so let me clear the question. So my question, when actually build the model, say for our neural network model, what we do to address the overfitting problem?
Yes, no, I'm not finding a specific answer.
Okay, the thing is like, right, so there are two approaches. Either we can drop out, so there is a concept of dropout, you will check it later, and there is another concept called early stopping. So,
I did
these
drop
are
out,
the things.
but I didn't.
Okay.
Yes, I did drop out 0.5, which actually like remove the randomly selected like features
Right.
from network to another network. So yeah, I did get one. But early stopping, I didn't actually do it. But I know.
Okay. So, did you apply any padding technique? So
No, I didn't apply. Actually, for the classification, our main focus was on segmentation. So for classification, I didn't actually as our segmentation work is still going, like for nucleus and cytoplasm. So for classification, that was a little bit extend work just for seeing that how ours work actually, and also in a different P10 model, because normally all of the people using BZ16 and all. So I tried something new like this efficient B3.
okay. So why then? My question is why actually you didn't compare NetB3 with BZ16 or YOLO? Right?
Oh,
There
yeah.
are other models.
Yes, like you are saying, why didn't I compare BZ16?
Right. Or why you actually consider NetB3?
Yes, because it is much smaller than BZ16 and it's not that much popular. That's why I have used this one, as because after the segmentation, this was experimental part for classification only. Like because in transfer learning, the nowadays it's so easy. Just you have to remove the fully connected layer and build your own fully connected layer and just merge it and increase the previous layers. That's it. So this one, yeah, you can see that you can say that I have I did use BZ16 as well as Raspberry 50, but I did not add it here. But you can say that I have choose this one as randomly. Yeah.
So did you show any kind of result or comparison of these algorithms or methods in your paper?
I didn't compare in my paper with my but I did compare with other papers who have classification and segmentation. There are like OTSU method, watershed method, and all. And classification, there are other pretend like this 60 resonated.
So the data you collected, is it publicly available?
Yes, it's publicly available. It's
okay. That means
yes, sir.
right. That means there are other results based on this data set, right?
Yes, this data is actually basically on segmentation. So whatever works I find is only one segmentation, and maximum of the segmentation was on watershed also and all. And Mascarson is quite unpopular as they seen it so far. That's why I use Mascarson, and I find it is quite good because because I start with only 10 images first of all, because I were to see how to run it or not. So even in 10 images, for training only 10 images, it is quite good detection in the testing. So then I thought that yeah, this approach is quite good, and it's little bit hybrid model. So it gives 3 outputs and all. So yeah, and
okay,
there are,
thank you.
Yes, yes.
I understand. Thank you very much. Thank you for answering the questions. So what I found that there is slight difference between the title. The title is actually showing in the slide and the title that I have.
Yes, actually one of the reviewers has asked me to change it, so that's why at the last moment I have to change it. So I don't know.
Right. Even normally I like to say that don't try to use like deep learning. So you are using a specific model, right? So why don't you can write the specific name? Like when we say deep learning, it's a really broad.
I thought about it, but I thought that it would be quite linear or something like that. But I did it at the last moment, so I didn't. I did try.
Okay, thank you for your participation.
Can I have a sure?
Yeah, Sandra, please.
Yeah.
Right, please.
Okay. My question is very simple. What is the output of your, as though you have written it classification, but I found that you use both softness and also regression. So what is the output actually, final output?
Final output is only one dimension. Like before that, there was like 10 dimensions of of output. My input features was for fully calculated, it was 2448. Yes, and then before final loss softness, that the output was 10. So then I have used the softness as a activation function. Then it only gives one output, one dimension. Yeah.
No, I also found that you also use regressor. So regressor actually it should output the continuous value, right?
But if you use lossless max, then there.
So far I can remember in your methodology, I have seen both in 2 different branching directions. First, it was saying softmax, that means it can produce the classification result, and other part I have also observed the regression. So what is the reason of that? I'm just asking.
I'm not actually which part was the regression? Actually, I didn't actually got this one. Because it was only image said only binary classification 0 or 1. That's it. So I'm not actually finding any continuous value.
And that's why I'm asking. I know since you told that this is a classification problem.
No, there is no.
You are using which train model?
Only my main focus on segmentation. So after that we are still working on that. So after that actually because pre-train model is quite popular and gives where.
So you know it to train again, right? But you should use those weights to your model.
Yeah, I can use that in custom.
But you told in one of your slides that you freeze the weights. What does it mean actually?
Yes, because pre-train model, their outputs, they are fully connected here. So if we have to normally what we do, we just omit those fully connected layers, then use our own fully connected layers. So there are outputs of other the pre-train models, you can say that efficient has been trained with billions of images on something like that. So those features, when you put the input, those features passed and all. So you have to, you can actually choose. You can like.
No. My question is very simple. That if you want to freeze the weights, then what is the use of using pre-trained model? You are freezing the weights. That means you are not using the weight of that pre-trained model. Then what is the use of using pre-trained model?
I'm not actually fully remembering right now, but there is a benefit of it. But I don't like. We can use the structure
Then I do not find any justification of using pre-trained model if you are not using the weights of that model.
But I did try to give you try in both ways by giving false and true. By not freezing and freezing. But
okay.
After freezing, it gives a like.
Okay, I'm done with my question. Okay, thank you.
Thank you so much.
Okay, thank you, Dr. Saddam. So I think this is the end of this session. So I would like to thank all the authors to participate in this session, and also I would like to congratulate them for their acceptance of the paper. So wish you all the best. So just to say that now the machine learning become very popular, and we have lot many tools and techniques to apply machine learning algorithms. But I really like to request you guys, please go deep into the algorithms. That's really important. Otherwise, we may miss something in the experiments. So thank you very much, all of you. So Sonnet, over to you.
Can we take a photo of all participants? I would like to request all to turn on their camera.
Okay, let me. Okay.
Please turn on your camera. We are taking the photos.
So I already turn on my one.
Okay, thank you everyone. I have taken the photos.